This video is the Semester 1 Fall Exam Review Part 2. All right, here, this is the recent chapter that we did. All right, so we want to make sure we know that the perpendicular bisector intersects to make the circumcenter, okay? The circumcenter, its special quality is that it is equidistant to the vertices of the triangle. Right? So that means all three of these thicker black lines are congruent as well. So we notice that this is a perpendicular bisector. You can tell by the picture because it has the congruent tick marks on either side of that point, and you see the little right angle marking, and that's on all three sides, so we know those are perpendicular bisectors. All right, the incenter is formed by angle bisectors. Okay, the incenter is also equidistant to the sides of the triangle. So these little segments right here that are actually perpendicular also are congruent. Those three little segments are congruent. And it's the angle bisector means that all of these angles are equal. Okay? Okay, so the median intersects at the centroid, and that divides our median into 1/3, 2/3 parts. So this divides our median into 1/3, 2/3 parts. Okay, so for example, I'm going to make this really big so I can write on the triangle. If this is X, this little segment from the centroid to the side is X, then the other one that's longer is 2 X's, and the whole CP is 3 X's. So whatever I give you for the whole segment, you divide by 3, and then one part goes on the short segment, and the other 2 parts go on the long together. Okay. The altitude is intersecting at the orthocenter. And that's right there. The altitude trying to get the right pen. The altitude is vertex to the side but it's perpendicular to the side. Okay, so see how I go from a vertex and then I go perpendicular straight down to the side. And then turn your triangle and do the next one. There's nothing else really important about an orthocenter except that it goes with altitude and it's sometimes outside the triangle. Okay, one more thing I forgot to mention about the median and the centroid. To find the coordinates of a centroid, So if you're given the 3 coordinates of the triangle, you take your average of your x's and the average of the y's, comma, then you take, okay, so the average of the x's, and then I'm going to take the average of my y's, and that, put a comma between them, and those are the coordinates. And remember, when you average, you add them all together and divide by how many there are. So there's 3 x's, you add 3 together and divide by 3, and that's the first number, and then you take your y's, add them together, divide by 3. All right. The next part is the triangle inequalities. The largest angle in a triangle is opposite the longest side. The blank angle is opposite the shortest side. The smallest angle is opposite the shortest side. And the sum of the lengths of any 2 sides of a triangle is greater than the third side. And to do the third side of the triangle, the range of that third side, we take our third side, I'll call it T, and we have to set it between the difference of the other 2 and the sum of the other 2. So like, for example, I had a triangle, and this was 6 and 4. So here what is T? Well, the range for T, it could be anywhere between 6 minus 4 and 6 plus 4, between 2 and 10. It cannot equal 2 and it cannot equal 10. All right, so let's do some examples of those. All right, which segment is the longest? Let's see. What is this angle? So I take 180 and I subtract 60. That gives me 120 minus 55. So 65. Okay, so which segment is the longest? That would be opposite my 65, so that's QR. What is a possible length of the third side of this triangle? Well, 9 minus 7 and 9 plus 7 has to be somewhere between 2 and 16. But it can't be 2 and it can't be 16. 18's too big, so 11. Which of the following sets of numbers can be lengths of the sides of a triangle? Well, I always take the big side and see if the smaller, and I know that if I subtract these two, that it's going to be smaller than the biggest. So my 14 has to be less than 9 plus 2. And that's 11, so it's not. Okay, 11. So 23 has to be less than 11 plus 12. That is 23. So it can't be that one. I take my big one, so this is C. I take the big one. I already know that when I subtract them that it's correct. So the 9 has to be less than 5 plus 3, and it's not. All right, so I hope it's this one. I take the biggest side, and I hope that it's smaller than the 8 plus 5, and it's 13, so that was the right answer. All right, So P is the in-center. Okay, how long is PE? Well, it's the same length as all these other ones, so I'm going to say 15. How big is angle ABC? Well, if this has to be 44, so that means this whole thing is 88. And ECP, so just the half of that. So this is 88. This is 64. So I have to add together those and subtract that from 180 to get this final side. And so I'm getting my calculator and I'm taking 88 plus 64 is 152. So I'm going to take 180 and subtract 152. And I get 28. But that's for the whole angle, right? So now I'm just going to divide by 2. And that's 14 for each side. Okay, cool. So in center, equidistant to the sides. Remember on the previous page. All right, centroid. U is the centroid. UK is 12. EM, that's the whole thing, is 27. And UD is 10. Okay, so we have to find out what CU is. Well, CU is the longer side to this 12. So that means it's twice as big. It's the 2x. If this is the x, that's the 2x. So that one would be 24. CK is 24 plus 12, which is 36. EU, oh, this is from the 27. Okay, so I take 27, let's do this in blue. 27 divided by 3 is 9. So one part is 9, the other part is 2 nines, or 18. Okay, so EU is the 18, MU is the 9. Okay, so here I have the long side, we'll do this one in green. I have the long side, 10, and it's 2 of the short part. So the short part has to be 5, because I divide by 2 to get that. So that's JU is 5, and then JD is 5 plus 10, or 15. And that is what is on the semester exam.